Anyone? What number we can represent? The smallest integer. Yeah, you can use your chat box. What value we can represent? Minus 128. Okay. So minus 2 to the power n minus 1. So minus 2 to the power 7, and that value will come minus 128. The second one, if R denote the number system radix, or it is also called the base. Okay, it is also called the base. So R radix or base both are same. Okay, then you have to find what is the value of R that will satisfy this equation called SQRT. This is a square root. Okay, so square root of 121 base R equal to 11 base R. Can you tell me what is the value of R? 1 to 1, square root of 1 to 1 base R equal to 11 base R. And the options are 10, 11, or both 10 and 11. The options are given like that. The first option is 10. Second option is given like that, 11. Third option is given 10 and 11 both. And fourth option is given none of these. Now you have to check how to find. What we have to write here? Anyone? This one we have written a square root of 121 base R equal to 11 base R. 121 base R equal to 11 base R. Now you can see how to write this value. So if you are going to square both sides, it will come 121 base R equal to what value will write here? Or if you are going to solve in the simple term, what value will write for the 121 base R? What value will write? We'll write the value equal to R square plus 2R plus 1 equal to R plus 1 whole square. Okay, R plus 1 whole square. Now you have to find the value for which this equation is true, or you can also solve this equation and find the value. Okay, so now you have to find the value for which this equation is true. So in this case, the value will come both 10 as well as 11. So the answer is both 10 as well as 11. Next one, that we will see how to represent hexadecimal format of 657 base 8. This is your base 657 base 8. So that we will see how to convert any base 8 to base 16 directly, how to convert base 8 to base 16. Okay. Now next one, if 73 base x, I have written base x, 73 base x is equal to 54 base y, then the possible value of xy, that I think we have already solved this type of problem. Okay, next one, the 2s complement representation of minus 15. Anyone, what is the 2s complement representation of minus 15? 2s complement of minus 15, how to write? How to write? So first we have to find the value that is slightly greater than this value. So 16 is the slightly greater than, so we will write minus 16. What value we have to add to minus 16 to get minus 15? We have to add plus 1. So that's why we are writing this. Your minus 16 means fourth place. Third place we are not going to write anything. Second place we are also not going to write. Third place, the second means what? First place, and 0th place we are writing. So this is the answer 10001. Okay. Same like that, if you are going to write minus 539, how to write minus 539 in 2s complement? Okay. The one way you have to find the binary representation of 539, and then you have to find the 2s complement. The second way, you have to find one value of the 2 to the power something that is slightly greater than 539. So can you take what value you can take? What value we can take? For 539, can we take the 10th value? 1024, right? 1024. 1024 means it is present at the 10th position. 1024. Okay. After that, what we will subtract? 1024 means that is coming minus 1024. What value we have to add to minus 1024 to get 539? Anyone? What value we have to add to minus 1024 to get 539? Anyone? What value you have to add? You can use your calculator. Okay. So what value you have to add to minus 1024 to get the value equal to 539. So most of the students are saying 485. 485. After that, if the next value you are going to write, that is the ninth position. So 2 to the power 9, what is the value you can take? 2 to the power 9. What is the value of 2 to the power 9? 512. So we cannot take 512 because this is 481. Okay. Next one. Can we take the 8th position? What is your 8th position? 256. Yes, we are taking 256. If we are going to subtract 485 minus 256, what value will come? What value will come? 485 minus 256. What value will come? 229. Okay. So next value again we are taking 128. So now we'll write 229 minus 128. What value will come? 229 minus 128. 101. Again we are writing 64. So 64. So 101 minus 64. What value will write? 101 minus 64. What value will come? 37. So again we are writing 32. So 37 minus 32. What value will come? 5. So we cannot take 16, we cannot take 8, we can take 4, we cannot take 2. Just say it is completed. This is one best procedure. But you can also convert. You can also convert 5 to 539. You can also convert 539 to binary number. So anyone, can you tell me what is the binary representation of 539 in this complement? So first the number is positive because we are going to find plus 539. Okay, so first number is positive, and after that we will write the value of 539. So can you tell me what is the representation of 539? Anyone? How to find 539? Again, you have to follow the division method. Follow the division method to find the value of 539. How to write 539? Okay, so one student have already written this value. 1 1 0. How many values to 0 जाते हैं? 4 0. So 1 2 3 4 0. Then 1 1 0 1 1. Okay. Now we'll find the 1's complement. What value will come? 1 0 1 1 1 1 0 0 1 0 0. Then we have to add 1, so we come 1 0 1 1 1 1 0 0 1 0 1. Now can you please check whether this values and this value are same or not? Just to check. 1 0 4 1 4 1 0 0 1 0 1. Now you can see. So directly you can also find this value, or you have to follow this approach. Okay. Clear? Now next one. Yeah, this question is also very simple. Next one. Can you please try to find which option is correct? Overflow means you are getting one extra bit. That is called the overflow. So in which case we will get the overflow when you are getting the first number. Both number is your 1 1. Then in this scenario we will get the overflow condition. Overflow condition means you are getting one extra bit. So as for example, if you are going to sum 1 1 0 0 and 1 1 0 0, what is the summation? First we will find 0 plus 0 0. Then 0 plus 0 0. Then we are going to find 1 plus 1 0. We are getting one values. Then 1 plus 1 plus 1, again we are getting 1, and after that we are also getting 1 at a overflow. Okay, so the answer will come 1 triple 0 if we are going to add this number. If we are going to add this two number, then we get the answer equal to 1 triple 0. Okay, can you tell me what is the decimal representation of 1 1 0 0? Anyone? If this number is written in 2's complement, what is the decimal representation of 1 1 0 0? What is the decimal representation? 0 1 2 3. So minus 8 plus 4 minus 4. So we are getting here minus 4 and then we are going to add minus 4. What value will get? Minus 8. Now you can see this value is also minus 8. Okay. So in this case, there is no any overflow because the first bit is your 0 plus 0. There is no any overflow. In this case, also, if you are going to check, can we get the overflow? Just you can see. Can we get the overflow? Anyone? Can we get the overflow? Yes, we will get the overflow. Okay. Now the last question, just we have to solve. Now I am going to check how many students are giving the right answer for this question. So what is the base? Radish means base. Base of the number if the solution of this quadratic equation x square minus 10x plus 31 equal to 0 is x equal to 5 and x equal to 8. It is already given like that. If you are going for the decimal number, yes, in the 2s complement, if the number is negative, then if you are adding 1 before the number will not change. Okay. If the number is positive and if you are adding 0 before the number will not change in case of 2s complement. Okay. So as for example, if you are writing 0, 1, 0, what is the number value? Just will take. What is the number value? Number value 0, 1, 0. What is the number value? If you are writing in the 2s complement, what is the number value? 0, 1, 0. 2. Okay. If you are going to add 5, 0, can you tell me what is the number value? Again, you will get the 2. Okay. So in case of positive number, if you are writing 0 before the number will not change. In case of negative number, if you are writing 1 before the number will not change. Okay. Overflow condition means whatever the result it is coming, you cannot store with the same number of bits. Okay. So as for example, if you are taking the 4 bits number, in this case, we are taking the 4 bits number. But if you are going to sum this value, it will come the output as 1, 1, 0. If you are going to sum this output, it will come as 1, 1, 0. So why? Because we are not going to store this value 1 here because we have only 4 space. We have only 4 bits. So this type of condition is called overflow condition. Clear? In some scenario, you will not get the overflow. If you are going to add the 2 positive numbers, you will not get the overflow. Okay. Now, next one, this one at least we'll try the last question. It is clearly mentioned like that. What is the base of this quadratic equation? If the solution to this quadratic equation is x equal to 5 and x equal to 8. Okay, if you are writing the normal solution in the decimal number, the solution is given x equal to 5 and x equal to 8. So now will tell me this 10 is written in what base, this 31 is written in what base. Okay. Now first you will tell me if the solution of any quadratic equation, the decimal solution is 5 and 8, can you tell me what is the quadratic equation? Anyone? What is quadratic equation? If we are going to write the solution of this quadratic equation is x equal to 5 and x equal to 8. So can we write the solution 8? Can we write x minus 5 into x minus 8 equal to 0. What is the value we'll get? X square minus 13x plus 40 equal to 0. Can we write x square minus 13x plus 40 equal to 0? Because it is clearly mentioned in the decimal the solution is x equal to 5 and 8. So in the decimal, if you are going to write the decimal, it will come like that: x square minus 13x plus 40 equal to 0. What do we mean by that? The number 10 written in some base r equal to 13. What is the value? We can find the value of r. What is the value? R equal to 13. If you are getting r equal to 13, now we have to check 31 base 13. What is the value we'll get? 31 base 13, 81. What is the value of 31 base 13? What is the value we'll get? 3 into 13 plus 1. 3 into 13 plus 1, and that value will come 1. Okay. So what is the output you will get? This number. What is the base of this quadratic equation? The base used to write this quadratic equation equal to 30. The base used to write this quadratic equation equal to 30. Okay. Clear? Up to here, anyone, any doubt? Up to here? Oh, anyone, any doubt? Okay, you have no any doubt. Okay. Now today we will write one program, the simple program, how to convert any base to the decimal number. Okay, so if number is given in any base, as for example, the number is given 789, or if the number is given something called 1011 or 2134 with base 5, or it is given 715686, how to convert this number to decimal number? How to convert this number to decimal? Clear? How to convert this number to decimal? Okay. First, we'll check one code here. Just you can see has include math.h. I'm writing has include math.h, and then we are writing printf percentile the UW power of 2 comma. Now will tell me what is the use of this UW. The output is coming here, and why it is printing 0? Just you can see. Okay. Printed equal to power of 3 comma 2 equal to 3 comma 2. Then we are printing the value of b. So now you can see what value it is printing. It is printing the value equal to 9. Okay, it is printing. Yes, you can write here return. Okay, it is printing the value equal to 9. Can you tell me what value it is printing? As for example, if I am going to change this value to 4, what value it will print? What value it will print? 3 comma 4. What value it will print? It will print 81. So now you can see we are going to check it, and it is printing 81. Okay, so here basically we are using one function called power that is used to calculate the x to the power y. That is used to calculate the x to the power y. Okay. Now we see the procedure how we are going to convert any number. As for example, 1011. Okay. Actually, my pen is not working, so we are writing like this. Okay, so 101. The base is 2, and if we are going to convert it to the decimal number, okay, what is the procedure? First, we are finding what is the last bit. Okay, what is the last bit of this number? Okay, how to find the last bit of the number? Anyone can you tell me? How to find the remainder? If we are going to what value, what types of operation we will apply to get the last bit of the number? There is also an operation called the modular division. If we are writing x modular division 2, then it will return you what is the remainder. As for example, 5 modular division 2, it will return you the value equal to, just will tell you, 5 modular division 2. What is the value it will return? It will return you the value equal to 1. Okay. If you are interested to get only this value, 1, how we will get this value? Anyone? How we will get this value? If I am going to write 1011 modular division 10, what value will get? What value will get? 1011 modular division 10, what value will get? We will get the value equal to 1. Same like that, if we are going to divide the number, if you are writing x divided by 2, it will only give you the quotient value. Okay, so as for example, if you are writing 5 divided by 2, it will give you the value equal to, okay, it will give you the value equal to 2. Okay, now you can see. First, I am going to write to convert any binary number to decimal number. Any binary number to decimal number. So here we are taking int b equal to, we are taking one binary number. Okay, this is your binary. Okay. Now after that, our main objective is to find what is the decimal representation of this binary number. So we are also writing int decimal equal to 0. Currently, we have not calculated the decimal number. So simply we are writing currently our decimal number equal to 0. Okay. So first we are writing what value we are going to convert to the decimal number. 10111. 10111 we are going to convert to the decimal. Okay. Now here the procedure is what we are going to do. If we are going to convert to the decimal number, we are starting from the right side and we are giving the number 0, 1, 2, 3. Means we need one counter that is used to count this value, or you can also say like that, what we are going to do like that. So here you can see based on this counter, just you can see what we are going to do. First we are finding what is the value of the last 1 into, we are writing 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 2 plus something like that. Means we need one counter that will count the total number of bits, the total number of bits purchased in this. After that, we are writing while. We are going to continue this process. While means when you are making the form. So I think in the lab, you have already means some instructor have already discussed the concept of while loop. Okay, in the lecture, we will also see what to mean by while loop. But the while loop is just like a one type of loop that will execute the same instruction more than one time. So if you are going to execute some same instruction more than one time, then you have to use the while. Okay. So now here we are writing, we are going to continue this process until the value of b greater than 0. Now you can see what we are going to do here. Just first we are finding int what is the remainder value, what is the last value, int b modular division. Clear? Int b modular division. We got the last value. Now we are going to find the decimal value. We will write b plus because we are writing the summation b plus whatever the remainder value is coming, the remainder into power of 2 comma. Once this procedure is over, we will increment the value of count plus 1 and then we will write b equal to b divided by. Okay, and after that, if we are going to print the value, we are writing printf percentile d. Now we have to check whether it is working or not. Yeah. So now you can see it is giving 23. Can you check what is the value of 10111? Anyone? What is the value of 10111? What is the value of 10111? 23. Okay. Now you can see the procedure. What we are going to do here. What we are going to do, simple, just you can see the procedure is very simple. We are taking this number 10111. Okay, our first objective is to get this number. What is this number? We are getting 1. How to get this number? This is your b. So how to get this number? We are writing b modular division 10. If you are writing b modular division 10, you will get the last bit of the number. You will get the last digit of the number. We are getting the last digit of the number and we have already made one counter. Counter equal to 0 means you are at the 0th position. And then we are writing 2 to the power 0. After that, we are incrementing the counter value and then we are writing b divided by 10. We are changing the value of b equal to b divided by 10. What is the value of b divided by 10? Anyone? What is the value it will come? 1011. It will only return the value 1011 if we are writing b divided by 10, because it will not return you the remainder value, it will only return you the quotient value and it will come 1011. So it will return you the value 1011. Okay, and after that the counter will come to the second position. Again we are going to find what is the last bit. Again we are writing b modular division 2. The last bit is 1 and we have already incremented counter by 1, so we are writing 1 into 2 to the power. Again, we are going to find b divided by 0. We are getting 101. Counter become 2. Again, whatever the last bit it is coming 1. So we are writing 1 to the power 2. Okay, 1 into 1 to the power 2. Plus. Again, we are dividing this one. We are getting 10. This counter value become 3. So we are getting the 0. So 0 into 2 to the power 3. Plus. Again, we are going to divide. It will come 1. So we are writing 1 into 2 to the power 4. And after that, if we are writing 1 divided by 10, it will come 0. And when we are getting 0, we are going to stop this process. It will only work when the value of b greater than 0. Okay. And here the counter is basically used to find this value 2 to the power 0, 2 to the power 1, 2 to the power 2. So that will give you the position value. That will give you the position. Clear? So any doubt in this code, how we are writing this code? Simple, we are using the while loop and this loop will be continue the process like that. So first it will calculate the remainder value, then it will find the key value and after that it will continue the same. Now assume that if we are going to write the same code using the other base, as for example, just you can see, I'm writing b equal to some base called 4, 5, 6 and base is 7. Where we have to modify the code so that this code will work for any base. I'm going to write int base. Okay, so int base equal to, we are writing here 7. Where we have to modify the code so that it will work for this base. If I am going to write this base to this. Okay, so now you can see it will work for any type of base. Just you can see it will work for any base 237. Now you can see if you are going to calculate the value, it will give you the 237. It will give you the 237. Good. It will give you the value equal to 237. Now the same question, just try to understand. The same thing if you are going to ask the user to enter the value and enter the base, and then you are printing the decimal number. Try to understand. You are asking the user to enter the value of B. If you are asking the user to enter the value of B, then here we can use one concept called scanf function. A scanf function that is used to take the input from user. So we are writing percentile D and of B. This is the syntax of scanf function that you will see more detail when we will discuss about the scanf and printf function. But if we are going to take the input from the user, simple, you can use the term called scanf percentile D and of B. Okay, means whatever the user will enter as an input, it will go and it will stored in B variable. Okay, it will stored in B variable. Same like that, we are also asking the user to enter the base. So we are writing a scanf percentile D, comma, and of base. Okay. Clear? So now in this case, what will happen like that? Now we are asking the user to enter the value as well as base, enter the value as well as base as well as base. No, this is not the condition. Definitely the value of B will come 0. Definitely the value of B become 0. I am not writing B greater than equal to 0. I am only writing B greater than 0. And if you are going to divide some number with the same number, definitely in future you will get the value equal to 0. And when you will get the value equal to 0, this loop is completed and it will come out from the loop. Now you can see. So if you are going to compile this, now you can see what we are going to give the number 10111. Okay. Now we are giving the base equal to 2. It is returning the value equal to 3. Now we have to check for some other cases. Just will tell you 3, 4, 5, 6, and base we are writing 7. Now this is the value 1, 2, 6, 6. You can also check like that. Now you can see. I am going to give the value 789 base 10. What value it will return? 789 base 10. So it is also returning the value 789. But the question is, just you can see, if we are going to write the value 456 base 5, what value it is returning? Can we say this is a real? Can we say this is a valid number? If you are writing 456 base 5 and it is returning the value equal to 131, can we say this is giving the right answer? No, this is not giving the right answer. Means we can say like that. This is not a valid number and we will not print anything. So what we have to do? Where we have to modify the code? We have to also check the value. If remainder value greater than, if your remainder value, whatever the remainder value is, coming greater than base value, okay, and even greater than equal to also the base value, then what we have to do? Just you can see what we are writing. We are going to check the condition. Whatever the remainder value is coming, whatever the position is coming, can we say this is greater than normal base? If it is greater than normal base, then in this case, this is not a valid number. So we write printf not valid. And then after that, we will stop the procedure. We are writing return. What we are going to do here? We are every time we are calculating the remainder, the last bit, and we are going to check whether the last bit is greater than your base or not. If it is greater than your base, then we can say this is not a valid number. This is not a valid number. So now you can see again we are going to check here. First we are going to check 1011 base 2. It is giving 23. There is no any problem. But when I am writing here the same thing 1021 base 2, now you can see it is giving this is not a valid. But how it is giving the not a valid number? When it will come the value of remainder equal to 2, now it will check the value. Whether the remainder greater than equal to base, yes, the condition is true, it will print the not valid, and after that it will return 0. When it will return 0, automatically the program is going to complete. 10. Return means this is the last line of the code. When you are writing return statement means, and the compiler is going to execute the return statement means this is the last line of the code. As for example, just you can see, I'm taking the new file and file save as and d.c. I'm writing the same code here. Okay. Now I'm writing printf bits, and we are writing the return 0. Then we are writing printf cs F111. Then we are writing the return 0. Then we are writing printf something called again Hyderabad. Okay. And then we are writing the return 0, and then we are writing here. Now we'll tell you what is the output of this program, because the compiler will start executing the program from here. It will print bits, and when it will get the return 0, when it will get the return 0, the compiler will assume like that this is the last line of your code, and it will not execute after that. Just you can see. So after, if you are going to compile and run, it is only printing the bits value. Why it is only printing the bits value? Because when the compiler will execute the return statement, it will assume like that all the instruction is already completed, and now it will complete the execution. Same like that, if I am going to remove this return statement, what value it will print? Bits CSF equal 1. If you are going to check bits CSF equal 1. The same thing we are doing here. When we are getting any value greater than base, then we are saying this number is not a valid number. We are saying this number is not a valid number, and this program will only work to convert. This program will only work to convert any base to decimal number, but the base must be less than equal to 10. It will not work for 11 base. It will not work for 12 base. It will not work for 13 base. Can you tell me why it will not work for 12, 13, and 14 base? Anyone? Can you tell me why it will not work? Why it will not work? Anyone? Can you tell me why it will not work? Anyone? Why will it not work? Because we are not going to store the character value, because after base 10, we are using some later. So that we will discuss when we will discuss about the string system. When we will discuss about the string, that time we will discuss how to convert any base to the decimal number, even the base 16, 20, 25, whatever the base you are taking, how to convert that base to the decimal number. Okay, how to convert that base to the decimal number. Okay, so up to here, anyone, any doubt for this code? Anyone, any question? Just you can see. Okay, if you have no any question, now we are going for the second one, how to convert a decimal to any base. Now the second question, because this program is only used to convert what? Any base to the decimal number. But the question is how to convert any decimal, how to convert decimal to any base. Okay, so now the procedure is same like that, the similar to like that. So we are going to write here in the next one. Okay, so now you can see. So first we are going to take the input from the user. Okay, so we are taking the same code and we are going to write D. We are taking the decimal number D as a input to the user. Okay, now we'll do it. What is the procedure after that? How we are going to convert a decimal to binary number or decimal to any base? We are also taking the base from the user. Just to take. Okay, so user is interested to convert to the base. Okay, now we got the decimal value and base value. If you got the decimal value and base value, what is the procedure? Next procedure, what we are going to do? Anyone? If you are going to simple. If you are going to convert 55, you can see. That is a different one. We are not going to discuss on the Python here. Okay, that is a different one. Okay. Now you can see what we are going to do. First, we are dividing this 55 with base. So now assume that we are going to convert to the base 2. So we are dividing 55 with base 2. Okay. And then we are finding what is the remainder value and what is the quotient value. Good. Okay, just we will try to remember the procedure. First, we are finding what is the remainder value and what is the quotient value. Now, will tell me how to get the remainder value if you are going to divide 55 with the base anyone. How to get the remainder value? Anyone. How to get the remainder value? We have to write 55 modular division 55 modular division 2, it will give you the base. And if you are writing 55 divided by 2, it will give you what value? 55 divided by 2, it will give you the quotient value. Okay, and we have to continue this process until we are getting the quotient value equal to 0. Right? Until we are getting the quotient value equal to 0, we have to continue this process. So now you can see we are writing the same thing while b value greater than 0. Find the b value greater than 0. We are writing int b binary. Then we are writing here b equal to b into 10. We are writing b equal to initially 0. So b equal to b into 10. Just will tell you what we are doing here. B into 10 plus b modular division base. D modular division base. And then we are writing d equal to d divided by base. Okay. And after that we are printing printf. Now we'll see whether it is working or not. Just you can see. After that I will explain. Now we are giving one value 55 or 23. 23. Now you can see it is okay. Just 1 second. Okay, so it is going to okay. We have to give the base also. Now it is printing the value 11101. Okay, can you tell me what is the decimal value of 11101? Anyone? What is the decimal value of 1101? Anyone? What is the decimal value of 11101? Anyone? Anyone? What is the decimal value will get? 20. Good. Okay. And what is the decimal value if you are going to reverse the number like 10111? 10111. Just we will reverse this number. What is the decimal value of 10111? Anyone? What is the decimal value of 10111? 23. I think it will come 23, not the 21. Okay. Now you can see our output is giving right, but it is giving in the reverse manner. Why it is giving in the reverse manner? I think you remember the procedure. When we are getting the output, we are writing in the reverse manner. We are not writing the forward manner. We are writing in the reverse manner. I think you remember this concept. So when we are going to find like that, just you can see if you are going for this one. Now you can see 55 modular division 2. What value will come? 1. And then what is the quotient value? We are going to divide it by this one. What is the quotient value? Just will tell me. What is the quotient value? 55 divided by 2. Anyone? Quotient value. What is the quotient value? 27. Now 27 divided by 2. What is the remainder value? 1. And what is the quotient value? 13. 13 divided by 2. What is the remainder value? 1. And quotient value 6. 6 divided by 2. What is the remainder value? 0. And the quotient value is 3. 3 divided by 2. What is the remainder value we are getting here? Remainder value we are getting here 1. And the quotient value we are getting 1. 1 divided by 2. Remainder value we are getting here 0. And the quotient, remainder value we are getting 1, and the quotient value we are getting 0. Just you can see. So this is the value. What we are going to write? We will write in the reverse manner. The output will come like that: 110 111. Can we say we are writing in the reverse manner? But here you can see what we are going to do. Whatever the value is coming here, 1. Now we are multiplying 1 into 10 plus. Second number we are going to find 1. What value will come? 11. 11 into 10 plus third value. Then you can see the procedure. You can see what we are going to do. B equal to B into 10. Initially value of B equal to 0. Now you can see what we are going to do. Just you can see. Because the programming is totally the logic. If your logic is clear, you can easily write the program. That will not take too much time. What we are writing here, B equal to 0. Now will tell me if I am writing B equal to B into 10 plus remainder value 1. What value will come for B? Just will tell me. What is the value of B? B will come 1. Okay, B equal to 1. Take one step. Now second case, again we are getting 1. So again we are writing B equal to B into 10 plus 1. What value of B will come? Just will tell you. What value of B will come? We are coming 11. Again we are coming to the third step. Again we are writing B into 10 plus 1. What value it will come? 111. Okay, but you can see we are writing in the forward manner. Now we have to convert this one to the reverse manner. So we are defining one user defined function called int. Just you can see int reverse of a number of int x, and then we are writing in reverse of a number called x. Here we are writing reverse number rb equal to 0, and then we are writing while x greater than 0, we have to continue this process. rb equal to rb into 10 plus rb into 10 plus x modular division 10, and then we are writing x equal to x divided by 10, and finally we are going to return the value of now you can see. Can you try to find how this function, we are defining one function called REB, reverse of a number, okay, int x, that will take any number, and then after that it will convert that number to reverse of a number. Now we'll see how this program will work. Okay, we are taking the x equal to simple code. We are taking x equal to 1011. Okay, we are taking simple x equal to 1011. Okay. Now after that, what is the value of RB initially? 0. Okay, then we are writing RB equal to RB into 10 plus x modular division 10. What value it will come? Just to tell you what value it will come. What is the value of RB? 0. 0 into 10, 0. And what is the value of x modular division 10? If this is x, this one your x, what is the value of x modular division 10? Just will tell me x modular division 10. What value it will return? It will return the value equal to 1. So if you are writing 0 into 10 plus 1, what value it will become? 1. And after that we are writing x equal to x divided by 10. What is the value of x divided by 10? Can we get 101? Can we get 101? X equal to x divided by 10. After that we are checking whether the value of x greater than 0 or not. Can we say the value of x greater than 0? Can we say 101 greater than 0? Yes, condition is true. Again, it will go RB equal to RB into 10 plus x modular division 10. Just will tell you what is the value of RB? 1. 1 into 10, 10. And what is the value of x modular division 10? 1. So it will become 1. Again, what is the value of x become? 10, because x divided by this one. Again, we are going for RB equal to RB into 10 plus x modular division 10. What value it will come? Just will tell you what is the value of this expression RB. What is the value of RB? 11. 11 into 10, 110. 110 plus x modular division 10. X modular division 10, 0. So it will become 110. Now again, x value equal to 10 divided by 10. 1. X value become 1. And again we are writing RB equal to RB into 10 plus x modular division 10. What value will become? 110. 1. After that, what is the value of x become 0? And when the value of x become 0, then in this case it will come out from the function and it will return to the. Now you can see in the same case, if I am going to write here REB of B, just you can see whether it is working or not. Just to try to check. Compile and run. Now you can see I'm going to give 23 base 2. Now you can see 10111. Can you check whether it is giving the right answer or wrong answer? Just can you please check whether it is giving the right answer or wrong answer? Anyone? 10111. If you are going to convert 23 base 10 to base 2, you will get the answer equal to 10111. Can we say this is the right answer? Can we say 16 plus 4, 20, 20 plus 2, 22, 23. Now same like that, just you can see the same like that I am going to check with 55, and we are writing the base equal to 3. Just you can see it is coming 2001. Can you please check? If 2001 base 3 equal to 55, can we say 2001 base 3 equal to 55? Can we say 0, 1, 2, 3? So 3 means 3 to the power 3, 27, 27 into 2, 54 plus 1, 55. Just you can see. Even if you are going to check any base, just you can see 7, 6, 7, 7, 6, 7, and we are going to convert to the base 8. Just you can see 1, 2, 1, 2, 4. Clear? So now you can see this. These are the two programs. The first program that is used to convert any base to the decimal number, and the second program that is used to convert decimal to any base. But again, it will only work up to base 10. It will not work after base 10. It will not work. the base. Clear? So if you have any question related to this program, then please ask. Okay, and that we will discuss. That we will discuss more detail when we will discuss about the scanf function, when we will discuss about the printf function. But currently, you can only remember if we are going to print integer value, you have to write %. If we are going to print float value, then we will see more detail. Okay, we will also see about the while loop. What do we mean by while loop? How to write the while loop? What do we mean by if statement? That we will also see more detail in next class. Okay, so up to here, if you have any question related to this topic, then please ask. Okay, and next class we will see about the conversion, means how to convert the binary to octal directly how to convert binary to octal, or octal to binary, or binary to hexadecimal to octal, something like that. That we will see in the class. Okay, so up to here, if you have any question, then please.
Hello.
Yes.
Good morning, sir. Sir, I just want to ask that which software we are using to program in C.
So
Currently?
mainly we are not using software. We are using one compiler called GCC compiler. Okay, so you can also write the same program online GCC compiler. If you are not interested to install the compiler in your system, then you can simply search online GCC compiler. Simply you search here online GCC compiler. Okay, and here you will go and write all the.
Thank you, sir.
Okay. Okay, if you are going to install some software, then you have to install Dev C++, Turbo C, or you can also install some other compiler. But in this lecture, we can only use the Dev C++.
Sir?
Yeah.
Sir, actually, I had a doubt.
Yes.
When we have written the code for converting a number from a specific base to decimal, we've been repeatedly dividing it by 10. What I had done earlier in Python, I was saying that I have used the indexing. Is that possible even here?
No, that is not.
Okay, sir.
Sir, did you write return 0 in the second program?
Yes, I have written the return 0. Just you can see. Return 0, if you are not there, you can write here return 0. There is no return 0.
Sir, but it won't show any error if it is not written.
If you are not writing the return 0, means it will execute all the code.
Okay, sir, got it.
Yeah, it will execute all the code. And when you are writing the return 0, means you are also getting the confirmation. And the compiler is also satisfied like that. I have already completed the task assigned by the user. Okay. So just you are giving one type of reward, something like that. So when you are writing the return 0, if you are not writing the return 0, the compiler is still confused whether I have completed all the instructions or not.
Sir?
Yes.
Sir, I have a doubt, sir. In case of a 2s complement number, like if we add two numbers which are in 2s complement, even if there is an overflow, it gives us the expected result, right, sir?
Overflow means simply we are discarding the number. Yes.
Yes, sir. But still, it gives us the expected answer, right, sir?
Yes.
But in case of like 1s complement and sign management system, we'll get the wrong answer, right, sir? In case there's an overflow.
Yes, we will get the wrong answer. Yes.
Okay, sir. So that's why the computer uses a 2s complement.
2s complement. Yes.
Okay, sir. Thank you, sir.
Sir. Thank you, sir.
Thank you.
Excuse me, sir.
Yeah.
Sir, I had a doubt from an earlier class, sir. On Monday, sir, we did a program in which you declared a variable in float equals to a equals to 2.2 and compared it with then 2.2 only, and it returned false.
Yes.
Sir, but when I use double data type in the same program, sir, it is returning true, sir.
It will return true.
Sir, can you explain why is it happening?
Yeah. So why it will happen like that? Just let's see. So I'm going to write open the front. Save action key dots. Okay. So now I'm writing this one simple program here. Just you can see. Check. Increment. Slow. And then we are writing printf percentile d, comma, percentile d, comma, height of a, comma, size of 0.2. Now you can see. what it is giving. Are you getting the point? It is giving like that. Whatever the float you have taken, okay, float A, that is taking the 4 bytes of memory to store the value. And when you are writing 2.2, it is taking the 8 bytes of memory. It is taking the 8 bytes of memory to store the value. Okay. In the previous Monday class, we have already discussed, if we are not getting the exact binary representation, from the number, it will return in the false state. But simple concept. Okay. Now will tell me, if someone will ask you to write the value of 1/2 in 5 bits number, up to 5 decimal, just will tell me what value you can write. If someone will ask you to write 1/2 in up to 5 decimal number, what is the answer we get? 0.5, and then we'll write 0, 0, 0. Can we write? Can we write? Yes.
Yes.
The same question, if it is going to ask, no, you have to write in 7 decimal number. What is the answer we get? 0.5 double. Can we say if there any difference between this number? Can we say if there any difference between this number? If you are writing 0.550 or if you are writing 0.570, there is no any difference. There is no, when you are saying the same thing. But if you are writing 0.3333 and then you are writing 0.3333, can we say if there is any difference?
Oh, okay, sir. Okay, sir. Understood.
The same thing here happened like that. Okay, so if you are not getting because the same number it is writing by using the 8 bits. Okay, 8 bits. If you are writing the same thing, just can see float a equal to 2.2, and then we are writing float b equal to also 2.2, and then we are writing here percentile d, and we are writing here a double equal to b. Now you can see what output it is printing. It is printing 1, means that is a true statement. Both are same. But when you are writing the same thing, if you are writing here 2.2, what value it will print? It will print with the false statement. Just you can see it is printing with the false. Why it is printing the false statement? Because when you are writing by default 2.2, it is taking 8 bytes to store the number. And when you are taking normal float, it is taking only 4 bytes to store the number. Okay, so in this case, you are writing 0.33 double equal to 0.33333, something like that. Can we say this number is equal? No. Just the same.
Okay. Thank you, sir.
Thank you.
Sir, so is 2.2 stored like randomly as double, sir?
Double. Yeah, by default, it will be stored as a double.
And 2.5 is stored as a float.
No, 2.5 also is stored as a double, but the difference, just you can see, it is calculating the difference. 0.50 minus 0.500. Tell me, what is the difference?
No difference, sir.
No difference. 0.33 minus 0.33333333. What is the difference?
Yes, sir, there is a difference.
Yes, this is the logic behind that.
Sir, so unless we mention float, otherwise all decimal numbers will be stored as double only, right, sir?
Yes, double. If you are writing, just you can see, if you are writing 0.33 minus 0.33. Difference?
It should be 0.
No difference. Right, 0. So if you are saying like that both are float, or if you are saying both are double, then in this case you will give me the right answer.
Yes, sir.
Good morning, sir. This
Yeah.
is Tanmay.
Yeah,
This is the first class for some of us guys here. Could you please give an overview? How do we guys proceed?
okay, so I have already sent you Google Classroom link. Okay, you will join the Google Classroom, and I have already uploaded all the recorded lecture here. Okay, so just to go through all recorded lecture. Okay, maybe in future we are planning to organize some extra class. Okay.
Okay, so as of now, we have to learn from the recorded lectures.
Recorded lecture, because just you can see, this is totally independent. Whatever the number system we have discussed, because the next class also we will discuss the number system, and after that we will start the main C language. Okay, so number system is totally independent from whatever the topic we are going to start from Monday. Okay.
Okay, sir. Thank you.
And for the number system, we may plan to organize one extra class. So maybe after 15th of November we will plan.
Okay. Okay, sir. Thank you.
Sir,
Yeah.
sir, at the beginning of the class, you explained a question with a quadratic equation, and you told it has solutions 8 and 5.
Yes.
I didn't get that question. Can you please explain it again?
Question is very simple. Question is like that. So now assume that this is the one equation written in some other base. Okay. So 10 written in some other base, 31 is also written in some base. Okay. And that base is given like that. Okay. So the base of this number is it is written like that. Base R. Okay. And this is also base R. Okay. Now it is saying like that. For the simple in the decimal, the solution of this quadratic equation is 5 and 8 in decimal number. Okay, if you are talking about the decimal, then the solution you are getting 5 and 8. If the solution is 5 and 8, what is the quadratic equation? We are getting x square minus 13x plus 40 equal to 0. This is the quadratic equation where we are getting the solution equal to 5 and 8. Right? Okay. Means in place of 13, you are writing the 10 base R. What is the value of R? So we can write what is the value of R. Now assume that if this base is R, what is the decimal value of this 10 base R? Can we say R plus 0? If you are going to convert 10 base R to any decimal number, what is the procedure?
R plus 0, yes.
R plus 0. So we are writing R plus 0 equal to 13. What is the value of R?
13, got it.
13, yes. Even you can also write here 31R, what is the value? You get 3R plus 1. 3R plus 1 equal to what you are writing? 40. So 3R plus 1 equal to 40. What is the value of R? 13.
Yes, got it, sir.
Excuse me, sir.
Yeah, tell me.
Sir, today is my first class, so I just wanted to know, do we have to download any application for programming, computer programming?
Either you can use the online compiler or you can download Dev C++. Dev
Sir,
C++.
can you please? Okay, sir.
Dev C++, DEV C++.
Excuse me,
Okay,
sir.
sir.
So this is my first class as well. So I just want to know which book should I refer. I have Yeshwan Kanetkar one. Will it be fine?
I think I have already shared one details regarding the book. Just to mention.
Please pardon, sir.
Basically, I'm going to follow this book, Pearson book. I'm going to check this book.
E. Balaguru Swami one.
Yes. Sorry. Problems solving and problem design, program design in C.
Sir, okay, 1 minute. Can you please send the screenshot of this book on Google Classroom?
Sorry?
Can you please send a photo of this book on Google Classroom?
Okay, so just to write problem solving and program design in C.
Okay. Thank you, sir.
Sir,
Yeah.
this is also my first class. So, sir, I just have to ask that is there any group of this class section?
No, there is no any.
So, like the meeting link will be posted on the Google Classroom only.
Yes, here you can see this is the link and that is common for all the class.
So, like you will only send the link in the Google Classroom, or any student will like because today
No,
any student like.
No, there is no any student. I'm going to share you again this link.
Okay.
Thank you.
Thank you, sir.
Sir, do we have to also mark our attendance somewhere?
No.
Okay, sir. Thank you, sir.
There is no any attendance policy.
Thank you, sir.
Thank you, sir.
Sir, who is the writer of that book? I just want to buy that book, so I just want to know.
Sorry?
Sir, who is the writer of that book? Writer and publisher?
Jerry H-E-N-L-E. J-E-R-R-I-R Henley, H-A-N-L-Y.
Okay. And sir, which edition?
7th edition. 7th edition. Yes, 7th edition.
Okay. Thank you, sir.